Bonjour Montréal. J'essaie de parler quelques mots en français. Je m'appelle Gerard. Je suis irlandaise, mais j'habite en Californie. Je suis le PDG d'Entekra. That's the end of my French. My high school teacher will be very happy. The first time I've actually said anything in a presentation in a foreign language, although it's not foreign to you, but it's to me. So I want to take you through, and a lot of this is going to follow up on what Robert said this morning with regard to where the US economy is with regard to housing. He said, I've spent 30 years of my life working in off-site construction. So in many times when I'm speaking at conferences in North America, although less so in Canada, because I know Canada is more advanced and there's much more use of automation and off-site construction north of the border than there is south of the border. So I'm not really, I don't mean to be seen to be condescending to my Canadian friends in this area, because I know you are, and I have a lot of friends in the industry north of the border. But I've been doing this for 30 years. To put that in context, wood frame as a method of construction is not necessarily the most common method of construction in Europe. It varies from country to country. I mean, if you go into Scandinavia, wood frame construction can be up as high as 90%. You get down into Southern Europe and it can be pretty much down to zero. But what is common in all of those countries is where wood frame construction is built, it's always built off-site. Europeans don't stick frame. Doesn't matter where it is. And by the end of this, I'll hope to explain why that's the case. So even to the extent that in Canada where they stick frame, and certainly in the United States where they stick frame, that's an anomaly to, I suppose, the rest of the developed world, that they're still using a method of construction that is, basically hasn't changed in 150 years. And where this manifests itself, and this comes back to what Robert was saying this morning, is if you take a look at that slide, I mean, to me, it's pretty shocking. If you look at where productivity has gone in manufacturing, the total economy, and then look at construction. I mean, that to anybody, I mean, a first-year economics student will tell you, there's something seriously wrong here. How can that be? We don't even have to leave this room. We should all, if we're connected with the building industry, be looking at that slide and saying, my God, we're connected to an industry that is backward. There's something wrong. That's followed up by, take a look, this is the US construction sector. It's actually worse than the world construction productivity. So, in actual fact, US construction productivity has declined over the last 30 years. Actually, in fact, US construction productivity has declined over the last 70 years. Now think about, there's the construction sector global, there's the United States. Look at this. Now there's the overall US economy, there's the overall global. Now, how can this be? How can that actually happen? That the country that developed the iPhone, put a man on the moon, developed Tesla, has that as a slide for their construction industry. I mean, I'm setting this up to say, but there is, I mean, you cannot, it is impossible to deny there is a ferocious problem within the US construction sector. Now, take a look at this. So you had Robert this morning talking about the labor shortage. But we really only have about 75% of the people currently available to work in the US construction industry as it stands at the moment. Yet, as Robert said this morning, we're underbuilding. What he didn't say was, if you take the US average, 30-year average for house building, it's approximately 1.5 million homes per year. It is stubbornly stuck at the moment at 1.25 million. There are 300,000 people short in the construction industry, and unemployment has pretty much been abolished. We're at full employment. At 4%, we're at full employment. So how do you get from 1.25 million to 1.5 million if you're at full employment? And the one slide that I don't have up here, but is equally probably one of the most disturbing of the whole lot, when Robert didn't talk about this morning, is if you think there's a problem now, you have not even seen the beginning of it. Because the current rate of attrition in the US construction industry is for every one person who enters it, and this is where this is going. For every one person that enters it, 5 are retiring. So if you think today's a problem, imagine 5 years from now what it's going to look like. It's going to be a ferocious problem. And you cannot, as a society, continue. I mean, what does Einstein say? If you always do what you've always done, you'll always get what you've always gotten. Think about it. Well, go back to the previous slides. That's what you're going to get. You're going to get this massive disparity between productivity and output. But then you take a look at material costs as well that are on top of that, as Robert mentioned this morning. So you have all of these going up as well, which are affecting the affordability of homes. But the reality is, what is the real problem? Is it rising costs? Is it a lack of labor? What's causing this? Well, in my opinion, it's an inefficient process. Right? To use another expression, say, if your current building process is labor constrained and you can't change the labor constraint, then QED, you need to change the building process. It's simple logic. So you can't just keep saying, I'm short labor, I'm short labor, I'm short labor, I can't build enough houses, I can't build enough houses, because not building enough houses actually drives the price of housing up, makes it actually more unaffordable. So the industry has got to find a solution, both for its own profitability and also for the people, for society as a whole. It's got to find a solution. So what is the solution? Well, Robert was mentioning this morning, we're talking about modular and panelized. I have an issue with that terminology. Because it's more than just modular, which Robert said is pretty much the whole house. And then you have panelized, which is a term that's really only used in North America, and particularly in the United States, which really refers more to lumber suppliers who happen to have lumber in their yard, and either on a part-time basis or maybe on a consistent basis, they'll make wall panels for the purpose of shifting lumber. For the purpose of shifting the commodity that they have in their yard, they'll go into wall panel production as an aside, but not as their primary or core business, with the objective of shifting the lumber. That's probably the single biggest reason why off-site construction hasn't penetrated the North American market to the extent that it penetrated the European market. Because a panelizer, to use that term, or a component manufacturer is not an off-site company. And an off-site company is not a panelizer. They have different DNA, and they look at the product on the market and the problem in a different way. An off-site company puts itself in the shoes of the builder, and its only objective is to try to find a more efficient way to build a home. It does not care about selling the lumber. It sells lumber as part of what it does, but its objective is not to sell lumber. Whereas the lumber company's objective is to sell lumber, and it's doing the panels as an add-on. And that fundamentally changes the approach, and it also fundamentally changes the benefits that the builder gets from an off-site solution. So what is it that we do? Well, what we call is to try to break or separate ourselves away from the rest of the US market, we come up with the acronym Fully Integrated Off-Site Solution, which is basically a combination of all of those terms: component, panelized, and prefab. It's a combination, because yeah, we do all of them. But the reality is, our product is made up of 2 items, a hard item and a soft item. The hard item you can see, which is the building components, the panels, the things that you can see on the building site. But as you can see here, we represent them as only being 20% of the product. 80% of what we do is in process improvement for the builder. It's about taking an inefficient process and changing the way they approach the building of the way they approach the building of the building. Our objective is to take what is a very elongated process and compact it, and basically build that house before it ever hits the building site, so that you're not stuck with these famous expressions that they use, the architects in south of the border use, field verify or check in the field. With offsite solutions, you can't do that. It has to be built before it's ever built. So you have to figure out the problem before you ever go to the site. That solves time on the site, and it makes people think about things up front. Because solving a problem on a building site is a hell of a lot more expensive than solving a problem in an office at a computer screen. And that's one of the clear things about offsite construction. Same thing about a car manufacturer, or else, if you think about it, I like to use this analogy. The single biggest piece of offsite construction probably ever carried out by mankind, or most difficult, is the International Space Station. Do you think that they ever wrote in the drawings field verify? No. Every single piece of that space station, they knew before it ever went up there how it was going to fit together and how it was going to work. But if you can do that with a space station, how come we can't do it with a single family home? What is so different about a home that we can't do it? Well, you can do it with a car, you can do it with a phone, you can do it with furniture, you can do it with anything. But somehow, the housing industry figures out that, no, it's so complicated it can't be done before it ever gets to the building site. That's what costs money. That's what slows down the process. Sorry, just to prove the point, these are all buildings that we did in my previous company in Ireland, Century Homes. So you can see everything here from custom homes to 4-story. This building here was actually Europe's first zero carbon home. It wasn't zero net energy, it was actually zero carbon. We had to offset the carbon content of every element in the building, and then it had to be carbon neutral in its operation. That was the largest single multifamily project in Dublin at the time. Was 1,500 units. That's all done by us in a factory. This building here, we just did for KB Home in Las Vegas at the International Builders Show, literally a month ago. So this house is built to the most technological advanced standards, using all sorts of technology that basically that's at the cutting edge. But again, that was all designed in Ireland, manufactured in California, and shipped to Nevada. House was up, the frame it was up with the roof on it, complete in 2 days. So what is the process? What makes off-site construction different from stick framing on site? Well, these are the integral parts of an off-site solution. And this is probably the single most important part. The rest of this only stem from this. That is where the energy has to go into. That's where the money is made. That's where the money is saved. So the process starts with taking a drawing. And I know a lot of people have seen this and said, well, it's common enough, it's done. It is. But it's the process. It's been able to do this on an ongoing basis with multiple different house designs to give the builder what they want and have no reduction in design flexibility. So we will take the building, produce a full set of CAD designs for it that can produce a computer-aided manufacturing file that will get sent to computer-aided machinery. But we will produce a 3D, which isn't showed here. We produce a 3D model of that building. So we can see every single clash, every single beam. We know where every single nail is. We can tell you how many nails are in the house before it's ever built. It will be built to tolerances that are plus or minus 1 millimeter over 10 meters. You cannot achieve it on a building site. The tolerance is smaller than the width of a saw blade. But that's what technology can do for you. That's why we use technology to build cars. That's why we use technology to make nearly every product that we use. So you're sending it directly to automated machinery. So the machinery is taking that same CAD file. Again, this is where the efficiency comes in because the work has been done. The work to actually run the machine has been done in the office. So when they're working out in the office to figure out how to design the house, they're actually making the manufacturing file to produce the house. Then when the components are loaded onto a truck, they're sequentially loaded in reverse order, so that as they come off the truck, they go directly onto the slab. So the building goes up as efficiently as possible. Now, I just want to show you an example. This is a house. This house is 3,800 square feet of total framed area that we did for Beazer Homes, a U.S. national home builder that we're supplying currently in Northern California. But just to show you how fast and how efficient a house can go up, and then think about this when people say there's a labor shortage. So that took 6 hours on site to get to plate level, and in 3 days, the roof was on the house and ready for the following trades to come. So when you put that in context, that same house, and we have actually shortened this. We've taken the best that the builder has told us was the time they could do it in. So their normal time to frame that house is 15 days. I've actually said we took 4 days when we took 3, just in case anybody says I was trying to go to put my best foot forward and not be fair in this. So even taking that, they were at 15 days or 71 man days on site. We were at 14 man days on site. That equates to a 507% increase in productivity. So when people say there's a labor shortage with regard to framing in the United States, to quote our president, that is fake news. The truth is, there is no labor shortage. What you have is people who are being forced and handcuffed to use an antiquated, outdated process. Use modern technology, use the computers, the CNC equipment, smart thinking, and you can build a house much more efficiently to the exact same design, and I'll go through this now in a second, but to a far higher quality than can be achieved on a building site. So there categorically is not a labor shortage. It is a process problem. The real question we have to ask ourselves is, why do we have a process problem? Not why is there a labor shortage? Because the other thing that's said about labor shortages as well, which is, again, sort of proves this point, one of the things that the building industry jumps around about when it comes to labor shortages is to say, well, we don't have any more shop classes, and we're not teaching young people, that's why they're not getting into the industry. That is complete and utter BS. The reason why we don't have shop classes is because our people don't want to go to them. Do you think a guy who grew up with an iPhone in one hand and an iPad in the other wants to go to a shop class, to go out to a building site in the muck and the dirt, picking up beams and start nailing them together? No, he doesn't. They don't want to do that. It's not because we don't have shop classes or we don't have people who want to go into the industry. It's because we have an antiquated industry that doesn't want to modernize itself that we don't have people who want to go into it. You can't expect people who use iPads, who have iPhones permanently attached to their ears, to want to go into an industry that hasn't modernized itself. If you want to bring people into it, young people into it, then you need to modernize the industry. Bring it up to date. So, the total number of days saved, by the way, so we said we were taking 11 days off the cycle time for the direct framing of that house. However, what that doesn't tell you is the additional savings in cycle time that were achieved because of the quality of the framing. And this is probably the hardest one I have tried to get across to people, but by the fact that that machine is operating to tolerances that are in the millimeters, it means that every other trade going into that house can get in and out of it faster than if that house was stick framed. And that doesn't matter whether it's the guy with the granite countertop, the guy who's putting down the tiles, or the guy who's putting in the kitchen cabinets. He can get in and get out of that house faster because of the accuracy of the frame than they could if it was otherwise built. So that, plus the fact that if you ask the builder how many days it was going to take to frame that house, and we said 15 days, but if you said to him, well, can you be sure and guarantee that you can have your plumber come in there on the 15th or on the 16th day and be sure that the house will be ready for him? He's going to say to you, no. So what he does is he allows 2 to 3 days of a buffer before he brings in the next trade, just to make sure, or as we would say in Ireland, to be sure. He wants to make sure that there's enough time there to guarantee that that house is complete so he can bring in the other trade. That's lost time to that builder. So the more you can get certainty into your schedule, the more you can shorten the schedule. The more you shorten the schedule, the more you shorten the cycle time. Now, if you take that cycle time, try and put a value on this, and this is the hardest one to actually do in the industry. Because when a builder will say to me, well, tell me this, how much cheaper or how much more expensive or what's the cost of your system versus stick framing it? My automatic response back to that builder is, I'm not going to even have that discussion with you unless you can tell me what the value of every day saved on site is worth to you. Because otherwise, there's no point in me having the conversation. Because every single day on site costs a builder money. The only thing we're arguing about is the amount of it. But it costs them money. Whether that's in interest charges, whether that's in security charges, whether that's in supervision charges, whatever it is, it's costing him money. Now, I can take an example of Glenn Cottrell from Ibicus in Pennsylvania did a research of the top 15 US home builders, and he analysed their accounts over the past 5 years. And he came up with a figure and said that in actual fact, he reckons that it works out about $850 per day. Now, it seems high to me. So, but even if it's not, even if it's 250 or 300 or 400, let's say it's $500 per day, that's $15,000 that we can take off, or we can profit that we can add back into the builder's back pocket. Or theoretically, the builder could reduce his price by $15,000 to make his house more affordable. You know, what Robert didn't say this morning, however, is if you ask a builder how much does he sell a house for, what's the answer to that question? Well, the answer is always the same. The maximum price the market will bear. So just because the builder can save $15,000 doesn't mean he's going to cut his price by $15,000. They're not charities. They will still try to make more money, which will make their investors happy. But nevertheless, an off-site solution not alone cuts the cycle time by the direct framing reduction, but also by the indirect cycle time reductions that are generated. Our calculation is that for the same number of people, the builder is easily going to be able to increase his output by about 25%. So again, go back to the situation of the undersupply of product in the market. This is a solution to increasing the output. But this is really what I wanted to highlight. To those of you who are in the building industry, that is the tolerances we are working to. Because that German machinery that we're running these walls down, that's the tolerance that it works to. That's the tolerance the Germans work to. It is literally millimeter perfect. What that does, it means those houses are a higher quality. You simply cannot. Everybody knows, it's well proven. Factory controlled conditions will always improve the quality above site controlled conditions regardless of what you're making. But that's an example of it. That is the tolerance levels that we expect from that machinery. That, on the other hand, is some of the stuff that we see out on building sites. That also goes back to this point, which may be of interest to people here as well. The type and quality of the lumber that we use is critically important to us. Because in order to achieve those tolerances on site, we have to use premium grade lumber. And also, in order to keep that German machinery working, it will only accept premium grade lumber. Anything else potentially causes it to stop. If it causes it to stop, it means we're losing money. So we're prepared to pay more to put higher quality lumber into the building in order to get the efficiency, because it's the efficiency that we use to get the lower cost, not just simply the material itself. Again, you saw, and you can see from here, this is that house in Las Vegas, Nevada that we did for Beazer. I mean, when that house, so that's actually on the third day. I mean, there's pretty much no waste, because if you don't bring waste to site, you don't generate waste on site. So, and then with the waste that we have in the factory, we recycle. That's an example of, that actually is, that's a house that we did in Turlock in Northern California. That particular day, we had nothing because the framer who was there took any of the lumber that we had, he took it away himself for his own use. We actually had nothing left when the house was up at plate level. Because there virtually is nothing anyway. The other thing that gets said is what it does is, again, with all these people who are going out of the industry, those 5 people who are retiring for every one that comes in, by the use of off-site construction, you can actually reduce the skill levels that are actually needed so you can get more out of the existing workforce, which is what Robert was talking about this morning. Other additional benefits are you get less environmental noise on a building site, which means if you're in built-up areas or you're even in a single-family tract where there's babies or children that are growing up, there's less noise on the new homes that are being built. It's a safer way to build, and it's not as prone to weather delays as stick framing is, so again, you can more guarantee your schedule and your output. But I want to leave you with this one final thought. So, you leave here this afternoon, and you decide you're going to buy yourself a new car. So you're going to buy a new BMW, and you walk down to the dealer, and you say, I'd like to buy myself a new 5 Series, sir. And he says, that's great. I'll give you 2 options. Option number 1 is I'll have all the parts shipped to your front yard, and I'll have 5 guys come out in a pickup truck with some welding gear and pneumatic tools and assemble the car in your front yard. Or I can have the car made in BMW's factory. Which are you going to take? Seriously. Hands up. Who wants it built in the front yard? Exactly. Why is a house any different? Why is a house any different? And why is the United States the one country? Because if you take it on both sides, you have Europe on one side and Japan on the other. Both of those, if you call Europe a country, it's a continent, but both of those countries pretty much build 100% of their wood frame construction off-site. And yet the United States doesn't. And yet they claim they have a labour shortage. Thank you.